All right, we have some more applications here. Number 3, we have 3 cards are selected from a regular 52 card deck. Find the probability that all 3 cards are diamonds. Okay, remember in a regular deck of cards, there are 13 cards in a suit. There are 4 suits, and the diamond is one of the suits. So as far as my total outcomes, there are 52 cards in the deck for which I'm going to choose 3. All right, so that'll be your total. So when I do my probability, what we need to think is, since there's 13 cards in a suit, I'm going to have 13, choose 3 cards, and then I'll divide that by the total. So you enter that just like we did in the other video. And we have that probability. So there's about a 1.29% chance of that happening. Okay, let's look at B. Find the probability that you pick exactly 1, 2. So this means one card that has a 2 on it. So this one's going to be a little bit different. We're still getting 3 cards. And this is where, what I alluded to earlier, we do the subgroups, and I can go back and show you how it works on the previous problems. It's also a nice check. So we're going to draw 3 cards still. Okay, as per right there. And they're going to be diamonds. So find the probability you pick 1, 2. So we're going to have the probability that we pick a 2. There are 4 2s in a deck. Alrighty, and one of them has to be a 2. So this is the group, okay, that is the 2. I'm going to put that in parentheses. That's the 2. Not a good place. It's going to bleed in with my other stuff. Let's put that up here. That's the success of getting a 2. Now, we got to get 3 cards, so I got to get at least exactly 1 2 and 2 other cards, but they can't be 2s. So in probability, and means multiply. In regular arithmetic, it means add, but in probability, it means a product. So what we have 48 remaining cards of these 4. And we've got 2 cards left, divided by the total, which is 52 cards, choose 3. So this is divided up into subgroups. This is what we have to have, and we have to consider what else we will get in the process. Now notice, this is a nice check because this 4 and this 48 have to add to this 52. This 1 and this 2 have to add to this 3. That's how subgroup works. Okay, so when you enter that, there's the setup. So I'll show you how on this one. I'll use the TI-30XS. So I'm going to have 4 combination. Be sure you pick combination of 1. Now, remember, it knows that that expression is a number. Times 48 combination of 2, or choose 2. It also knows that that's a number, and you can immediately hit divided by 52 times the combination, or divided by the combination 3. Okay, so you'll get 0.20416. Okay, and the same thing is true on this calculator. Okay, so we'll do that one as well. Okay, 4, arrow to the combination, choose 1, times 48, combination, choose the 2, the other 2 cards that can't be 2s. We're going to straight up divide that. Notice the symbol's a little bit different. 52, combination, choose 3. You get exactly the same number. Okay, so find the probability that you pick at least 1, 2. Now that's different than exactly 1, 2. That means we could get 1, we could get 1, we could get an additional 2 card, but we could also get a third card. So I want to bring up this idea of complement. That's a P. The complement of the word at least, in other words, it's kind of the opposite, is none or no whatevers will happen. Okay? When we have an event that takes place, its complement, and the way I notate it is like a little apostrophe by the E. A lot of books do it differently. I think our book does it this way. This is complement, okay? The probability of the complement is 1 minus the probability of the event happening. Because think about this, remember, 100% is high as you can go. So if I know how many outcomes come here, then I can get the complement probability by subtracting that from 1. So we use that idea when they talk about at least whatevers, okay? So the complement here, the complement of at least 1, 2 is the probability of no cards with a 2. Okay, so we're going to use that idea. So what I'll do is I'll go, that's 1 minus the probability of no number 2 cards. That's the same thing. That is equal to the probability of picking, I didn't leave any room, I'm sorry, at least 1, 2. Okay, so I could get a 1, I could get a 1 card that's labeled a 2, like say a 2 of clubs, I could get a 2 of diamonds, and then maybe I could get a 2 of spades. But that's at least. And so the only way we can find that, or the easiest way I think, is to use the idea of the complement. So the idea of getting no cards, so I've got 48 cards that aren't 2s. Okay, and this is the total number of cards out of the 3 we're going to choose. And then when we enter that in the calculator, you can literally say 1 minus 48, choose 3. And I think on this one, just to make me feel better, I am not going to try this without a parenthesis just because. And then that's 52, choose 3. Okay, so that's going to be a 0.217375566. Okay, which is what I have on the other. Okay, so let's look at number 5. Well, let's just pause this one and we'll come back to it.